Good morning, students. Chapter 5, Magnetism and Matter. In this lecture, we will see one important topic, that is null point. Now, what is meaning of null point? Null point means something is zero at that point. Yes, null point in case of electric field means electric field zero. Null point in case of current means current is zero at that point. So yes, what is null point? Means where resultant magnetic field becomes zero. Where resultant magnetic field becomes zero. Okay, yes. We know that magnetic field of Earth emerges from geographical south pole and enters through geographical north pole. Yes or no? Yes, please. Okay, if it is horizontal component of magnetic field, it is horizontal component of magnetic field, BH. Okay, BH, horizontal component of Earth's magnetic field, BH. Horizontal component of Earth's magnetic field, that is BH. Yes or no? Yes, we know that. Okay, and yes, in this horizontal component of Earth's magnetic field, if I place one magnet in horizontal plane, suppose one magnet is placed like this. One magnet is placed like this. Okay, one magnet is placed like this, having its north pole in this direction and south pole in this direction. Yes or no? So in this region we have two types of magnetic field. One due to Earth and another due to this bar magnet, and another due to this bar magnet. We know magnetic field lines of magnetic field of Earth. Now I will draw magnetic field lines due to this bar square. Okay, now sorry, bar magnet. It is its axis. Yes or no? So yes, on axis, magnetic field lines emerges from north pole outside in this direction, and in south pole inside, and in south pole inside. Yes or no? It is magnetic field line. Also, magnetic field line of magnet like this. Magnetic field line of magnet like this. Okay? Like this. Like this. Like this. Clear about this? Okay? Again, magnetic field lines like this. Okay? Yes. Magnetic field lines of bar magnet. Magnetic field lines of bar magnet. Clear about this? Now, null point means what? Null point means where resultant magnetic field, that is sigma B is equal to 0. Where resultant magnetic field becomes 0. Now, when you have two magnetic field, then what is condition? The total magnetic field becomes 0. Yes, magnitude must be same and direction opposite. Magnitude must be same and direction opposite. So first of all, we will find points where direction of magnetic field due to Earth and due to bar magnet are in opposite direction. Yes, direction of Earth's magnet, white chalk, it is in this direction. So we have to find points where magnetic field due to bar magnet is in opposite direction. Is in opposite direction. Is in opposite direction. So see, if I take this point, due to bar magnet, magnetic field at any point is in direction of tangent. So if at this point I draw tangent, it will be in this direction. So is it in same direction? No, it is not in same direction. If you observe each and every point on this axis, if you observe each and every point on this axis, see here, magnetic field on axis, it is in this direction, in this direction, in this direction. And what is magnetic field of Earth? It is in this direction. So for each and every point on axis, this BH and magnetic field of Earth, they are in same direction. They are in opposite direction. For each and every point on axis of magnet, this BH and B, they are in opposite direction. But opposite direction is not only condition. Okay, also same magnitude. So yes, I am assuming that from this center, I am assuming that from this center, let at distance r. Let at distance r means at this point. At this point. See, it is clear from figure. At this point, due to bar magnet, it is magnetic field. It is magnetic field, that is P. And yes, at this point, what is magnetic field due to Earth? Yes, it is in this direction. So yes, BH is in this direction. Yes or no? So yes, from center at distance r. At this point, if they both have equal magnitude, then here resultant magnetic field will become 0. And yes, this point is called null point. This point is called null point. Clear about this? This point is called null point. Okay. Similarly, one null point will be at distance r. Will be at distance r this side. Will be at distance r this side. Null point. And why? Because again, due to magnetic field is in this direction, and horizontal component of Earth's magnetic field, it is in this direction. That is BH. That is BH. Clear about this? So null point means where resultant magnetic field becomes 0. Where resultant magnetic field becomes 0. And 0 means the two fields are the opposite direction and magnitude same. So at null point, how to write? Yes, I can write B is equal to BH. B is equal to BH. Clear about this? Clear about this? So yes, when magnet is placed like this, okay, then null points are on axis. Null points are on axis. Null points are on axis. Clear about this? Okay, yes, this magnetic field lines, we know that Earth's magnetic field lines emerges from South Pole to North Pole. So yes, here it may be South Pole of Earth and here it may be North Pole. Or we can say it is geographical south, it is geographical. Clear about this? Okay? Okay, so yes, this point you have to remember. Now, if I rotate this magnet by 180 degree, if I rotate this magnet by 180, you see, Earth's magnet, it is in same direction. Earth's magnet, it is in same direction. BH, it is in this direction. Okay, BH, it is in this direction. Yes or no? BH is in this direction. Now, if I am rotating magnet by 180 degree, if I am rotating magnet by 180 degree, means it will become North Pole, it will become South Pole. Magnetic field lines, axis, North Pole out, South Pole in, like this. Okay, from North Pole out, South Pole in. Yes or no? Again, North Pole out, South Pole in, like this. Yes or no? Yes, like this. So now, where null points will be obtained? In this case, see, if you observe first axis, on axis, magnetic field due to magnet in this direction and magnetic field due to Earth is also in this direction. So on axis, null points are not possible. So at which point null points will be possible? Yes, what is condition? Magnitude same and direction opposite. Direction opposite. On these such points, there are no possible ways where direction will be opposite. There are only two cases possible, on axis or on equator. See, on equator. Magnetic field line is in this direction. On equator, at this point, yes, at this point, if I draw tangent, then yes, magnetic field B will be in this direction. So see, on equator of magnet, magnetic field due to bar magnet and magnetic field due to Earth, they are in opposite direction. So yes, here null point is obtained on equator. Similarly, one null point will obtain at this point, because again, Earth magnetic field due to bar magnet. At this point, magnetic field is in direction of tangent. So B and BH, they are in opposite direction. So here at null point will be obtained. From center at distance r. From center at distance r, null points are obtained. And yes, again at null points, I can write B is equal to BH. B is equal to BH. Clear about this? this? Yes, if null points are obtained on axis, I can write BA, magnetic field on axis. If null points are obtained on equator, I can write BE is equal to BH. Clear about this? So yes, it depends how magnet is placed. It depends how magnet is placed. Okay, in this case, null points are obtained on axis. In second case, null points are obtained. Null points are obtained on equator. Null points are obtained on equator. Clear about this? Clear about this? So yes, in this case, null points are obtained on equator. Okay. Now it is theory. It is theory. One extra theory. What is null point? Now we will see some questions based on this null point. See, exercise question number 5.13. Exercise question number 5.13. You are given a short bar magnet. You are given a short bar magnet which is placed in horizontal plane such that its axis is in geographical north and south direction, and in such case null points are obtained on axis at 14 cm from center. Earth's magnetic field B is equal to 0.36 Gauss, angle of D is phi is equal to 0. Your question is, what is total magnetic field on the normal bisector of magnet at the same direction, at the same distance as the null point? Now see, understand question. Here, first of all, Earth's magnetic field B is equal to 0.36 Gauss, phi is equal to 0 degree. So what is BH? BH is equal to, it is B cos phi. So it is B cos 0, means it is B. So it is 0.36 Gauss. Yes or no? Yes it is. Yes or no? Yes it is. Now, short bar magnet is placed in horizontal plane such that its axis is coinciding with north and south, and null points are obtained on axis. Again I will draw figure. See, here it is, horizontal component of magnetic field BH in this direction. BH in this direction. Yes, magnet is placed like this. Magnet is placed like this. It is north pole and it is south pole. So, due to magnet, what is magnetic field? From north pole outside, from south pole inside. Yes or no? So on axis, the two fields are going in opposite direction. What we have to find? We have to find what is magnetic field on bisector, perpendicular bisector. So see, if I draw magnetic field lines like this, if I draw magnetic field lines like this, from north outside, in south inside. Clear about this? Okay. So see, at this point on equator, magnetic field at a point is in direction of tangent. Magnetic field at a point is in direction of tangent. So at this point, magnetic field due to magnet B, it is in this direction. Yes or no? And yes, it is on equator, so I will write it as B. Okay. So on equator, magnetic field due to bar magnet BE in this direction. Horizontal component of Earth's magnet BH, it is also in the same direction. They do have same value. They do have same direction. They do have same direction. Clear about this? Clear about this? Now, how to find this? How to find this? Okay, see, null points. You are given null points are obtained on axis at 14 cm from center. So yes, from this center, null points are obtained. Null points are obtained at distance 14 cm. R is equal to, it is 14 cm. R is equal to, it is 14 cm. So here, null point on axis at R is equal to 14 cm. When null points are obtained on axis, what is the relation between magnetic field due to magnet and horizontal component of Earth's magnetic field? Yes, for null points we know that BA is equal to BH. BA is equal to, it is BH. Yes or no? Yes it is. Yes or no? Yes it is. BA, what is equation of magnetic field? We know that it is mu 0. It is mu 0 upon 4 pi. On axis it is 2m upon r3. It is 2m upon r3 is equal to, it is BH. It is equation number 1. It is equation number 1. Yes or no? Yes, please. Yes. You are given value of mu 0 upon 4 pi. You are also given value of r, but you are not given value of m. Okay. You do not have to find value of m. We will take it in short. Okay. Now, what is total magnetic field on the normal bisector of magnet at the same distance? At the same distance. At the same distance r. What is magnetic field at normal bisector? So see, at normal bisector, magnetic field due to short bar magnet and BH, they are in same direction. Okay. At normal bisector, magnetic field due to short bar magnet and BH, they are in same direction. So therefore resultant magnetic field at point on equator, B dash is equal to BE plus BH. Yes or no? Yes, it is. BE plus BH. Now you know equation of BE. What is magnetic field on axis of an equator? It is mu 0 upon 4 pi m upon r cube, because you are given same distance. Plus here it is BH. Plus here it is BH. Yes or no? Yes. Now how to solve this? See here. There is equation. From this equation, make mu 0 upon 4 pi into 2m upon r cube as subject. So from this equation, see how your calculation becomes easy. Here I want to find value of mu 0 upon 4 pi m upon r cube. Here what is mu 0 upon 2m r cube dh. Make mu 0 upon 4 pi m upon r cube as subject. So 2 in this side, it is dh by 2. Clear about this? You are given same distance. On axis at distance r, on equator at distance r. So yes, mu 0 upon 4 pi m upon r cube is equal to this bh by 2. So I will place this value here. So it will become, it is bh by 2 plus here it is bh. Simple? Yes or no? So yes, here it is 3 by 2. Here it is 3 by 2 bh. Clear about this? Okay, and yes, you are given what is value of bh. bh is equal to b cos phi is equal to b cos a is equal to b is equal to 0.36 Gauss. Put value of 0.36 Gauss. You will get your answer. Clear? If you know concept, okay, yes, what is equation of magnetic field on axis, what is equation of magnetic field on equator for same distance, what is relation between them, then your solution becomes short. Clear about this question? Okay, yes, again, in this case, as magnet is placed like this, null points are obtained on axis. And on equator, resultant magnetic field is BE plus BH. Clear about this? Now, if I ask you our question, if this magnet is rotated by 180 degree, then obviously null points will be obtained on equator. Okay, so yes, next question is 5.14, in which the magnet is rotated about its axis about 180 degree. Then you have to find where null points will be that. Okay, so we will find this. Now, what is 5.14? See, we have solved 5.13. If magnet in 5.13 is rotated by 180 degree, where will the new null points be located? Yes, we know. Okay, new null points will be located at on equator. Let at distance r, at distance r. So I have assumed that they are obtained at distance r. Okay, now we know that when null points are obtained on equator at distance r, what is condition? Yes, we have proved okay, when null points are obtained on equator at distance r, we know that mu 0 upon 4 pi. We know that mu 0 upon 4 pi. Yes, what is condition? BE is equal to BH. BE is equal to BH. Mu 0 upon 4 pi M upon R cube is equal to BH. Yes, you are given value of BH 0.36 Gauss. You are given, you have to find what is value of R. R is equal to question mark. Mu 0, 4 pi into 10 raised to minus 7. 4 pi you are given, but M you are not given. But M you are not given. So first of all you have to find what is value of M. In exercise 5.13, in exercise 5.13, you are given that initially null points are obtained. Null points are obtained on axis. Null points are obtained on axis. So we know that on axis BA is equal to BH. So here it is mu 0 upon 4 pi 2m upon r cube is equal to, here it is BH. Yes or no? In this case, what is value of r? It is 14 centimeter. What is value of BH? It is 0.36 Gauss, means 0.36 into 10 raised to minus 4 Tesla. So yes, it is from exercise 5.13. Null points are obtained on axis. So I can write BA is equal to BH. Mu 0 upon 4 pi 2m upon r cube is equal to BH. R is given, BH is given. So you can easily find what is value of M. Yes. And now that value of M you have to put here. That value of M you have to put here, and you have to find what is distance. What is distance? Clear about this? So yes, it is one question 5.14 in which is related to 5.13, in which magnet is rotated about 180 degree. Magnet is rotated about 180 degree. Clear about this? Okay. Now we will see one another question. Exercise 5.15. Exercise 5.15. See, exercise 5.15. A short bar magnet having magnetic moment 5.25 into 10 raised to minus 2 joule per Tesla is placed such that its axis is perpendicular to Earth's field. Is perpendicular to Earth's field. At what distance from the center of Earth the resultant field is inclined at 45 degree? First on its normal bisector and then on its axis. Earth's magnetic field is equal to 0.42 Gauss, or we can say is 0.42 into 10 raised to minus 4 Tesla. See, first of all we will understand one general concept. Here it is. If I have one magnetic field B1 in this direction, another magnetic field B2 in this direction, okay, another magnetic field B2 in this direction, and they are perpendicular to each other. These two magnetic fields are perpendicular to each other. And if resultant magnetic field, that is B is resultant magnetic field B, if it makes angle 45 degree, it makes angle 45 degree with any magnetic field, because these two magnetic fields are perpendicular to each other. These two magnetic field B1 and B2, they are perpendicular to each other, and if the resultant vector, that is magnetic field B, makes 45 degree with any of two magnetic fields, then obviously in this case, according to law of parallelogram, magnitudes of two magnetic fields are same. Magnitudes of two magnetic fields are same. Clear about this? So yes, this result you have to remember. If two magnetic fields are perpendicular to each other, if two magnetic fields are perpendicular to each other, okay, resultant makes angle 45, or we can say this resultant equally divides. If I have two vectors like this, it is vector A and yes, it is vector B, and the resultant is R in this direction. R is in this direction. Then obviously, if this angle is 30, then this angle is also 30. But in this condition, A is equal to B. In this condition, A is equal to B. Clear about this? Clear about this? So yes, B1 and B2 perpendicular to each other. Resultant magnetic field makes angle 45 degree with makes angle 45 degree. Okay, then yes, in this condition, B1 is equal to B2. Now here, we are given a short bar magnet and we are given earth. So yes, B1, that B1 is magnetic field. B1 is magnetic field due to bar magnet. Due to bar magnet. And B2 is magnetic field. Is magnetic field due to earth. Is magnetic field due to, okay, so yes, if resultant makes angle 45 with earth, then it means B1 is equal to B2. So if resultant makes angle 45 degree, then magnetic field due to bar magnet is equal to magnetic field due to earth. Magnetic field due to earth. And what is magnetic field due to earth? Here it is B2. Here it is renamed B2 is equal to 0.42. Now you have to find two questions, A and B. A on normal bisector. On normal bisector. Normal bisector means equator. Normal bisector means equator. And on equator, yes, what is magnetic field due to magnet? B1, it is mu0 upon 4 pi m upon r cube is equal to B. Yes, mu0, 4 pi into 10 to minus 7, 4 pi, that is 4 pi m. You are given B2, means here it is 0.42 into 10 to minus 4 Tesla. You have to find what is value of R. Simple. You have to find what is value of R. Simple. Yes or no? Yes. In this question, how to find C? Yes, it is again on, in this case, it is on axis. It is on axis. On axis, B1 means magnetic field due to magnet. It is mu0 upon 4 pi. Here it is 2m upon r cube is equal to, it is B2. Is equal to, it is B2. That is magnetic field due to earth. So again, here you have to find what is value of R. Here you have to find what is value of R. Clear about this? Clear about this? So yes, it is one question which is based on resultant magnetic field. You have to understand this concept. You have to understand this concept. Clear about this? Right now.